the equilibrium of charge.
Yes, sir.
Equilibrium of charges. Okay, so the net force we have to equate it to 0. Okay, so now say for example, if you have similar charges, okay, similar charges, you have similar charges. Say you have got similar charges. Now here you see, I got similar charges. Now one is Q1 and other one is Q2.
Q.
These two are similar charges. Now you can have a charge Q,
Yes, sir.
okay, at a point O. Let us take the distance between them is x.
Yes, sir.
Distance between the charges is x. So imagine a positive charge here. So this is going to push in this direction and this is going to push in this direction.
Yes, sir.
So the net force will become 0.
0. Yes, sir.
Okay. Net force will become 0. At the same point, the net electric field also will become 0.
0. Yes,
Okay.
sir.
So you take this distance as x and one distance as so total distance you take it as d.
Yes,
Distance
sir.
from one of the charge is x, then next one will become
Yes,
d minus x.
yes,
So now let us take this charge as q. Then the force this pushes this one q1 in this direction. Let us call this as f1. So
yes, sir.
f1 is equal to f2. If these two forces are equal, then the resultant force will become 0.
0. Yes, sir.
So it is k q1
Q.
into q by x
R.
square, that is equal to k into q2 into q by d
D
minus
minus X whole square.
x whole square. Now
Yes,
this q and q gets cancelled, this k and k gets cancelled. So what we get is d minus x by x is
yes, sir.
equal to q2 by q1
Q1.
square root of this. Okay, now
Yes,
by substituting the values, we get the distance x and we can calculate d minus
X.
x from this.
Yes.
Okay, if this is a case for similar charges.
Similar topic.
Now, now if you have dissimilar charges, dissimilar charges, dissimilar charges mean. Now let us take this as Q1 and this as Q2, and the distance between them is is D. Okay, now these are dissimilar charges. Dissimilar charges means one is plus, other one is minus.
Minus.
Now, if I take in the middle at the in between the charges, then this is going to push in this direction and this is
Yes,
going to attract in this direction. So, in between these two, I may not get any point where the electric forces is equal to 0. The sum of electric forces is equal to 0 because everywhere they will add up, because
yes,
this
sir.
is going to push in this direction, this is going to attract in this direction. So, in between Q1 and Q2 it is not possible. So
Yes,
what
sir.
I do is we have to consider a point which is
The point charge is always
outside.
positive, sir.
Now yeah, test charge is always positive.
Yes, sir.
Test charge is always positive. Okay, so we will consider here, even if you take negative charge, then also you won't get in between.
Yes,
Okay,
sir.
now so here we take this as Q. This distance is, this distance from here is
X.
x. Okay, so
Yes, sir.
now you calculate force. So this one is going to push q in this direction, I'm calling this as F1, and this one is going to attract in this direction, and that is F2, and F1 and F2 should be equal. So
Yes, sir.
F1 is equal to F2.
F2.
Now F1 is equal to F2, then we get K Q1 into Q by what is the distance? D plus X is
Plus
the
X.
distance.
Yes, sir.
D plus X whole
Whole
square,
square.
that is equal to K Q2 into Q by X square.
Yes, sir.
Okay, so
Yes,
here also we get here D plus X by
X.
X
Two.
is equal to, so here k and k will get cancelled, q and q will get cancelled. I have brought it here. D
Yes,
plus x by x is equal to
root
q1
of
by q2
Q. Whole.
square root of this.
Yes, sir.
Okay, so that's the point where we get the net electric field as 0, or the net resultant forces as 0. The net electric field will also be 0 at this point, and
Yes,
that
sir.
point can be called as a null point.
Yes, sir.
Okay, so okay, right.
Yes, sir.
Now for now we will discuss about a freely suspended charged particle. Okay,
Yes,
right.
sir.
In equilibrium of charges, we will discuss one more point: freely suspended charged particle. Freely suspended
Large part.
charged particle. Freely suspended charged particle. Now freely suspended charged particle, here we have two. One is negative and other one is positive. Now here I will take a positive charge, okay,
Yes, sir.
and see what are the forces acting on it. This positive charge, see, this is plus q. Now that will be pushed up
Yes,
by
sir.
the electric field in this direction, and
Yes,
that force is F, and mg is acting downward. So F is equal to mg. F is equal to mg. What is this F? F is equal to, here due to, this is due to uniform electric field. So F is equal to QE.
QE. Yes, sir.
QE is equal to
MG.
mg. So how much electric field has to be applied, or how much electric field has to be applied means E is
MG.
equal to
MG by
mg
Q.
by q.
Q. Yes, sir.
E is equal to mg by q.
Yes,
Okay, that is uh, then that is E value, electric field. Now if you want q, q is equal to mg by E.
sir. E. Yes, sir.
We can write. Okay.
Yes,
Now
sir.
right. Now, in case of string, say charged particle suspended by a string, by strings. Okay, charged particle suspended by suspended by
String.
string.
Yes,
Okay,
sir.
suspended by string. Here we can write this case. Say you have a positively charged, uniformly charged rod, and then you suspended one positively charged particle. Say let us take this charge is plus q.
Yes, sir.
Okay, then this is in equilibrium. This is in equilibrium, then what is theta there?
Theta.
Now
Yes,
here you will have tension T. You
yes,
draw
sir.
a line which is straight. Now this line is parallel to this one, so this is the transversal. So if
Yes,
this is
sir.
theta, this is theta,
Theta. Yes,
then
sir.
this is T
Cos
cos
theta.
theta,
Cos theta.
and
Yes,
this
sir.
is T
T sin theta.
T sin theta, and vertically
mg,
downwards we'll have
mg.
mg. And
Yes.
this this produces electric field which pushes in this direction, that is equal to q into E.
E. Yes,
As
sir.
this is in equilibrium, equilibrium means sigma fx is equal to 0 and sigma fy is equal to 0. Now sigma fx is equal to 0, I can write t sin theta is equal to QE.
Yes, sir.
Sigma Fy is equal to 0. So here I will write T cos
Cos
theta
theta.
is equal to mg.
Mg. Yes, sir.
Let us write this as equation 1 and this as equation 2. Then equation 1 by 2, if I write T sin theta is equal to QE,
QE by
and T cos theta is equal to
mg.
m mg. Then if I do, then sin theta by cos theta is
Tan theta.
tan theta. Tan theta is equal to QE by
Mg.
mg.
Yes,
Okay, so the angle also we can write theta is
theta is
equal to
tan inverse
tan inverse
QE by mg.
QE by
Mg.
mg.
Yes,
Okay,
yes, sir.
right. So the electric field is directly proportional to tan theta.
Tan theta.
Okay, if
Yes, sir.
electric field is more, tan theta will
Tan
be
theta is
more.
more. Yes,
More.
sir.
Yeah, if the for right. So now, now equilibrium of suspended point charge system. Next, we are going to discuss about two strings which were given positive charge. Okay, so they were given positive charge. Say this is plus q1, this is plus q2. Then you take the angles as here theta and here theta. Then I will draw the tension here. So this tension is T here, this tension is T here, and draw a vertical line which is just parallel to this one. So here if it is theta, now you see this
Tan
line and this line are parallel, and that is theta. So here
theta.
you write theta. This is
T cos theta.
T cos theta, and
Yes.
in this direction you will have
T
T
sin theta.
sin theta, and in this direction you will have electrostatic
QE.
force of repulsion, Fe. And now
Fe. Yes,
here
sir.
this is not due to this is not due to the electric field, this is due to the point charge. So
Yes, sir.
um,
Fe.
Fe.
Yes,
Okay,
sir.
let us take that this distance between these two particles is x.
X.
Okay, then downward force
Mg.
mg will act. So if the particle is in equilibrium, then I'm going to write sigma fx is equal to 0. The sum of all forces along x-axis is equal to 0. That means Fe is equal to T sine
Sin
theta.
theta.
Fe means you can write here, this is K q1 q2 by x square.
Yes, sir.
Okay, that is equal to, you can write
T
it
sin theta.
as
Theta.
t sine theta.
Yes, sir.
And here we can write sigma fy is equal to 0. Sigma fy is equal to 0 means t cos theta is equal to t cos theta is equal
Mg.
to mg.
Yes, sir.
Okay,
Yes, sir.
now here this you can write it as so now I'll put this one as equation 1, and I'll put this as equation 2, and then I will write equation 1 by 2. Equation 1 by 2 is going to give me t sine theta is equal to Fe, and the second equation is T cos theta is
equal
equal to
to mg.
mg. Then T and T gets cancelled. Sin theta by cos theta
Tan
is
theta. Tan
tan
theta is
theta.
equal to
Tan theta is equal to
Fe
Fe
by
by
mg. mg.
mg. Then
Yes, sir.
theta is equal to
Tan inverse Fe by mg.
tan inverse Fe by mg. Okay.
Yes, sir.
So these are the equilibrium conditions.
Yes, sir.
Okay. Now next one is done, completed.
Completed, sir.
Okay. All right. Now next one is charged circular ring electric field due to
Charge
charged
circular ring.
circular ring. Now you take a charged circular ring. Now this has
Yes,
got a positive charge here.
yes, sir.
Now imagine that is a ring. Now its radius is r.
Yes,
Its
sir.
distance
X.
is x.
Yes, sir.
Its distance is
X.
x. Now at this distance, what is the electric field? The electric field at that distance, E on the axis. E on the axis is equal to 1 by 4
Yes.
pi epsilon
Epsilon
naught qx by r square plus
naught
x
x square
square whole
whole power
power
3 by
3
2.
by 2.
Yes, sir.
3 by 2. This is the electric field at the axis.
Yes, sir.
Okay. Now, if the if you consider that it is at the at a very large distance, if it is at a very large distance, then this very large distance means no. Say at the center, say for example here at the
Yes, sir.
center, if you want at the center, now E at the center will become 0. Why it is becoming 0? Because we are putting x is equal to 0.
0. Yes, sir.
Okay, x
Yes,
is
sir.
equal to 0.
0.
Why x is equal to 0? If you put here, now you
Yes,
can
sir.
see here, now these charges are all around like
Yes, sir.
this. Now here, this will be pushed in this direction, in this direction, in this direction. So this charge will push in this direction. This charge will push in this direction. So every charge, if
Will
it
be
pushes
cancelled.
downward, yeah. For
Yes, sir.
every charge, there will be an opposite charge which pushes in opposite direction. So the net field will become 0.
0.
So at the center of the ring, it will be equal to
0.
it will be equal to 0. Okay,
Yes,
so if x is very much less than r, then we are going to get e at the axis is equal to the axis is equal to this x square can be neglected, so we get 1
1 by
by 4
4 pi
pi
on
epsilon naught. So see here. um This you will get it as qx by if you neglect this one,
Yes,
this
sir.
will become
R
r cube.
square. R cube. Yes, sir.
See, r square whole power 3 by 2.
Yes,
This
sir.
2 and 2 gets cancelled and you will
Cancel.
get r cube, and x square I am neglecting because
Yes,
it
sir.
is very, very small.
Let
Okay, when that means you take the particle very close, then 1 by 4 pi epsilon naught qx by
R cube.
r cube. Okay, so that is the electric field due to the circular
Ring.
ring.
Yes, sir.
Okay, right. Now, we will discuss motion of a charged particle. Motion of a charged particle. Motion of a charged
Particle.
particle. Motion of a charged particle. So now we'll consider a electric field. Electric field means always you have to imagine a straight current carrying conductor in that positive charge is given. Then it produces uniform electric field, right? Uniform
Yes,
electric field. Now in this electric field, what I do is I place one charged particle, okay, plus q.
yes, sir.
Then what happens here? It experiences some force. What is the
Repulse.
force? Force acting on the body. F is equal to QE.
QE.
F is equal to QE. So force is equal to mass times acceleration. That is equal to
E.
QE. Then acceleration is equal to
E by M.
QE by M.
M. Yes, sir.
So after a time t, what is its velocity? Velocity is equal to u plus this acceleration is constant because the field is constant. So v is equal to u plus at. So
Yes, sir.
v is equal to u is 0. Initially it is at rest. Then
Yes, sir.
plus qe by
QE by M
m
into T.
into t. So v is equal to qe by
E by
m
M
into
into
t.
T. T.
That is velocity.
Sir,
If
M
it
is
has
mass
got
of the
some
charge.
m is mass of the charged particle.
Yes, sir.
Okay. Now, if you want what is the distance traveled, then distance traveled s is equal to what is the formula? Ut plus
UT plus half AT.
half at square. Now
Yes, sir.
here the initial velocity I am taking it as 0,
Zero.
so
Zero.
that's why this term is becoming
So is
0.
on zero.
Or else if it is having some initial velocity, then you have to write ut also. Okay,
Yes, yes.
so half into
QE
QE
by
by
M
M
into T
into
cube.
T square.
Into T.
T square na
Okay.
here.
Yes, sir. Yes, sir.
A value is QE by M. T square is this. Okay. So similarly, we can calculate momentum also. Momentum is what? Momentum. Momentum is p. P is equal to mass into velocity v. Okay.
Yes,
So v is equal to qe by m into t. So m qe
by M
by m
into
into
T.
t. So
T.
this m and m gets cancelled. So
T.
this
E.
is qe t.
T. Yes,
Okay. Then you can write the kinetic energy also. The kinetic energy is equal to half
half
m
A
v
square.
square. That is equal to half m into q square e square
Uh,
t square by m square. So this m and an m square will get cancelled. Get q square e square
one
t square by
by 2M.
2
2M.
2m
Yes,
is
sir.
the Kinetic
Kinetic energy.
kinetic energy. Okay,
Yes, sir.
right. Now, so this is motion of the particle.
Yes, sir.
Okay, motion of the particle. Now, let's write electric flux. Electric flux. Okay, now electric flux phi is equal to integral of E dot ds. E
Yes,
is electric field, ds is area. Okay,
yes, sir.
E dot ds is equal to flux is equal to my Gauss law says it is q in by epsilon naught.
Epsilon naught.
Okay,
Yes,
now
sir.
what is this q in by epsilon naught? See, if you are having if you are having charges, say here q1, q2 minus q3
Yes,
minus q4 and q5, then flux through this closed surface is equal to flux is equal to q1 plus q2 minus q3 by epsilon naught. You should take only charges which are inside but not outside. The flux due to the charges outside is equal to 0.
yes, sir.
Because this is when it produces electric field line, this will be incoming flux, this will be outgoing flux. So
Yes,
the incoming flux is equal to outgoing flux. So the flux produced by the charge which is outside is going to be 0.
0.
Okay, so only which are inside that flux only you need to consider.
Cal- Yes, sir.
Okay. The total electric flux through the closed surface enclosing a charge is 1 by epsilon naught times the magnitude of charged enclosed. That is
Yes, sir.
called as Gauss law.
What?
Okay. Now see here the say now you have a cube. Okay.
Yes, sir.
You have a cube and a charge q is placed here. Then what is the total flux through the cube? Total flux through the cube is equal to q by epsilon naught.
Yes, sir.
Okay, now flux through phase, through one of the phase. So how many phases it has? Four,
6
above one,
phases.
below one, six phases.
Yes,
So
sir.
flux through phase is
Phase
equal to q by
6
6
epsilon naught.
6 epsilon naught.
Yes, sir.
Okay, now if he says sometimes he will give a question like this, say there is a ball like this. Okay, you got a charge here. Okay, half
Yes,
of it
sir.
this is inside and half of it is outside. So
Outside.
what we do is we cover this one,
Yes, sir.
then it becomes a closed surface.
Yes,
Then
sir.
the upper one, his upper hemisphere is having q by epsilon naught and the lower one is having
Q
q
by
by
epsilon
epsilon,
naught. Yes, sir.
because now here the charge shared is q by 2 by the charge
Epsilon
share
naught.
by this one is q by 2 because only half of it is inside. So charge
Yes,
inside
sir.
is only q by 2.
Q by
So
2.
the flux is q by 2
2 epsilon naught.
to epsilon naught. Say if I give you a surface and say okay charge q is there, then the flux through that is q by epsilon
Epsilon
naught.
naught. Yes, sir.
Now if I give you a, a charge, say cylinder, if I consider a cylinder and I place it here, half of it is inside and half of it is outside, then
Yes.
q by
And 2
2
epsilon naught.
epsilon, because
Yes,
the
sir.
charge inside is only up to half.
Yes, sir.
Okay,
Yes, sir.
so right. So now here when we have a hemisphere like this, now the field is going like this.
Yes, sir.
Now here charge is not there, na? So we have to go with E into A. So
Yes,
here E electric field into area of this hemispherical body is pi r square. Here through this area only, na, it is going.
yes, sir. Yes, sir.
That is pi r square. So E into pi r square is the flux.
Yes, sir.
Okay.
Yes, sir.
Now if the charge is placed at the edge, say now this is a uh,
You.
cube,
Yes, sir.
this is a cube, and half of it is inside and half of it is
Outside.
outside. Then half of it is inside, so the flux of the flux inside the cube is q by
2
2 by
epsilon naught.
epsilon. Or else
Yes, sir.
this one we can argue that to make it a closed surface, because Gauss law is for closed surface, so to
Yes,
make it a closed surface we require
cube.
one more cube. So
Yes,
you
sir.
keep that cube here, so
Yes,
then
sir.
it will be enclosed. Then for this one it is q by 2, and that one charge enclosed is q by 2. So charged enclosed is q by 2 epsilon naught for this cube. So flux
Yes,
is
sir.
equal to q by 2 epsilon naught for this cube.
Yes, sir.
Okay.
Yes, sir.
So right. Okay. Now in this one of the question is, if this is placed at, if this is placed, if the charge is placed at one of the corners, then if it is placed at the corner like this,
Yes, sir.
then what we have to do is, now here below four spheres, sorry, below four cubes, we require four cubes
Yes, sir.
to cover.
Yes, sir.
Okay, because this charge is here like this. Okay,
Yes,
so
yes,
to
sir.
close this one, if it is at one of the corner, if it is at one of the corner, then you require four cubes to cover the bottom and four cubes to cover the top. So
Yes, sir.
total eight cubes are required to enclose it.
Yes,
So
sir.
the flux will be equal to
Q
q
by
by
8 epsilon naught.
8 epsilon naught. This is the flux shared by each cube,
Corner.
and you are placing at the
Corner.
corner.
Yes, sir.
Okay,
Yes, sir.
right. Now we will discuss some applications of the Gauss law. One of the application is it is mainly used to find the electric field. Now if you say electric line of charge, if you take a line of charge and it is having positive charge, then what is the electric field? Now electric field at this point, then what you have to do is you have to consider a cylindrical Gaussian surface,
Yes, sir.
a cylindrical Gaussian surface at this point.
Yes, sir.
Okay, we have to enclose a cylindrical Gaussian surface, and let us take that distance is r.
R.
Then flux is equal to integral of
E
E
dot ds.
dot E dot ds is
E
E eds eds is equal to, now how much charge is there inside the Gaussian surface? This
S
charge we have to take, that is equal to q by
epsilon naught.
epsilon naught. So this E into integral of ds, this is 2 pi r into L, where this
Yes,
is
sir.
the length.
Yes, sir.
2 pi RL is equal to q by
Q epsilon naught.
epsilon naught.
Yes,
Okay.
sir.
So E is equal to q by
2 pi RL epsilon naught.
2 pi RL epsilon
Epsilon.
naught.
Yes, sir.
Okay, but this charge per unit length is called as lambda.
Yes, sir.
So lambda by
2 pi R epsilon naught.
2 pi r epsilon
Epsilon naught.
naught.
Yes, sir.
Okay, that's how you calculate the electric field for a infinite
Cylinder.
infinite line of charge.
Infinite line of charges. Yes, sir.
Okay, infinite line of charge. Okay, this is one application.
Yes, sir.
Okay, now we will do for remaining applications, like for a sphere. Okay, and all
Yes,
we
sir.
will calculate the electric field. Now, what is the electric field due to a sphere?
Electric field due to a sphere.
Yeah, charged conducting sphere. So I will take a charged conducting sphere and we'll discuss about the electric field.
Yes,
Charged conducting sphere. Charged conducting sphere. So if you take a charged conducting sphere, then let us take its radius is r and the charge is q.
Q.
Okay.
Yes, sir.
Now if the point is outside, if a point is outside, then the distance is r. Now this is conducting sphere, so all the charge will reside only on the surface.
Surface.
There's no charge on the inside.
Inside. Yes, sir.
Okay. Due to repulsion, even if you place charge inside, it will come onto the surface. Okay. Now at
Yes.
this point, we have to calculate the electric field. R greater than R. What does it mean? That means E outside.
E
Electric
outside.
field outside the sphere is equal to
Yes.
1 by 4 pi epsilon naught q by r
R.
square.
Yes,
Q
sir.
by r
R.
square. Now R is equal to R. R is equal to R means electric field on
Surface.
the surface.
Surface.
On the surface, it is 1 by
1,
4
4,
pi
5.
epsilon naught q by r
R
square.
square.
Okay.
Yes, sir.
R is equal to small r.
Yes, sir.
Now inside, what
Yes,
how we got this one, because we just I just applied the Gauss law. See,
yes, sir.
if the point is outside, then I took one sphere. Okay, Gaussian
Yes,
surface here. When I
yes,
took
sir.
Gaussian surface here, then I wrote E dot ds is equal to q by epsilon naught. Okay, E is
Yes, sir.
equal E into, now the surface area is 4 pi r square. So 4
Yes, sir.
pi r square is equal to Q by epsilon
Epsilon
naught.
naught.
So E is equal to Q by 4 pi epsilon
R.
naught into r square. So same as this 1 by 4 pi epsilon naught Q by r square. So what
Yes,
you
sir.
have to do is, wherever you want the electric field, there you have to consider the Gaussian
Gaussian.
surface.
Yes, sir.
Now r less than
the
r,
R.
that means inside E will be equal to 0. Why E
0.
will be equal to 0? Because if I consider a Gaussian
Cancel.
surface inside, Q in is equal to 0 because there is
Yes.
no charge here. So
Yes.
E will be equal to
0.
E will be equal to 0. When I draw the graph between electric field and the distance, now at r, till then it will be 0.
Yes, sir.
E will be 0, and here you will have maximum value. The maximum value is at kq by capital R square is maximum value, and from there you will get like this,
Yes,
because
sir.
here E is inversely proportional to
R
R
square.
square. We get a graph like this.
Yes, sir.
Okay. Even for a hollow sphere also you will get the same thing.
Yes, sir.
Hollow sphere also we get the same thing. Okay.
Yes, sir.
You just have to take E dot ds is equal to q by epsilon naught. If you
Okay.
want here, you consider a
Gaussian
Gaussian
surface.
surface there.
Yes,
Then
sir.
4 pi r square is equal to q by epsilon naught. So E is equal to q by 4 pi epsilon naught
R square.
r square you will get.
Yes,
Okay. Right. So we need to draw the graph. Then what happened to a charged non-conducting sphere? So now we will discuss a charged non-conducting sphere. Charged non-conducting charged non-conducting sphere.
yes, sir.
Now if you consider a charged non-conducting sphere, a charged non-conducting sphere, then it is uniformly distributed like this. Okay.
Yes, sir.
Now I'll consider a point P is outside. Then you consider, let us take this charge as Q. Now you consider a Gaussian surface here. Then
Yes, sir.
you apply the
E
formula.
dot
A
yes.
dot ds is equal to q in by
Epsilon naught.
epsilon epsilon naught.
Yes, sir.
E dot ds is equal to q in by epsilon naught E into 4 pi.
4
The
pi R.
radius of the Gaussian surface is
4 pi R square.
r.
R. Yes,
So
sir.
ds is 4 pi r
4
square.
pi
Area is 4 pi r square. Charge is q
U by
by
epsilon naught.
epsilon naught. So E is equal to q by 4 pi
4
epsilon naught
R
r
square.
square. So
Yes,
E
sir.
is equal to 1 by 4 pi epsilon naught q
Q
by
by R
r
square.
square.
Yes, sir.
When E is outside, that means when the radius is the Gaussian surface radius is greater than r. If
Yes,
r is equal to r is equal to r means here Gaussian surface is
yes, sir.
here. Then total charge enclosed is q. So you will get E into ds is equal to charge
1
enclosed is q by epsilon naught E 4 pi. Radius of the Gaussian surface now
R
is r
square.
square. So that is q by
Q by
epsilon naught.
epsilon naught.
So E is equal to 1
1
by
by 4
4
pi
pi
epsilon naught.
epsilon naught q by
Q by capital R square.
capital R square. So this
Yes, sir.
is ES. This is on the
Surface.
surface.
Yes, sir.
And R less than R.
0.
R less than R, not 0. Now here you will have some charge. That's what.
Yes, sir.
Here you have some charge inside. So you cannot write
Zero.
that as
Zero.
0.
Yes, sir.
Okay.
Yes, sir.
So at a r distance, you have E in, electric field inside is equal to, electric field inside is equal to 1 by 4 pi epsilon naught. This is
Q R.
QR by
Q R.
QR by RQ.
Yes, sir.
Okay.
Yes, sir.
So E inside is directly proportional to R.
Yes, sir.
Okay. Directly proportional to R. When R is equal to 0, at the center it is equal to 0, of course.
Yes, sir.
Okay. But E in here is directly proportional to
Proportional to R.
small r.
Yes, sir.
So now if I draw a graph that, so electric field and distance, if I draw a graph, this is electric field and this is distance. Now here E is directly proportional to R, so is directly proportional to R. Now here R is equal to R, and then it is inverse relation because E outside is 1 by R square, and
Yes,
it is maximum at the on the surface KQ
yes,
by R square.
R square.
This is the
R
shape of the graph.
star.
Okay,
Yes, sir.
done.